Section 1. Why water science matters and molecular hydrogen. Water is the most abundant molecule in the human body and the foundation of nearly every biological process. Every cell depends on water to transport nutrients, regulate temperature, remove metabolic waste, maintain electrical balance, and support cellular chemistry. Yet, water is often treated as though all forms are essentially the same, but they're not. For many years, water research focused mainly on purity and contamination issues like bacteria, heavy metals, etc. And, obviously those are major health concerns. But over the past several decades, researchers have also begun asking another question. Could the physical and chemical characteristics of water itself influence biological systems? Well, we're finding that with all the pollution and everything, by the time water gets to your tap, it certainly has been altered. And then does just filtering those contaminants out do the trick? Well, scientists are finding out otherwise. Um, that question has become of growing interest in several areas of research, including things like molecular hydrogen in water or electrochemistry of water, ionized water, bringing the electrochemistry back to a more natural state of negative charge, dissolved gas dynamics. Those kind of things are just being researched. There's also mineral balance and that kind of thing. Your body needs buffers, and we do need alkaline buffers a lot of times, especially if your diet is too acidic. So, the possible structural organization of water molecules might have a difference and make a difference. And so, a lot of researchers have been doing work in this area. Two particular technologies that have come out of this research. The first one was water ionizers, and those have been around for 50, 60 years and have developed a lot of popularity. They still are very popular, even though a newer technology for hydrogen water machines has arisen more recently in the last 2 decades. Water ionizers, in my opinion, are still every bit as important of a technology, and they have been improved as well over the last couple of decades to include more hydrogen content. But both technologies alter the water in measurable ways. It can be measured, and we'll talk about that in the last section of this page. Now, the discovery that changed hydrogen science was done by Dr. Ota back in 2007. And actually, his research was for several years, and just he wrote an article that made it to a very prestigious magazine, Nature magazine, in 2007. And what that article coming out did was it alerted a large body of researchers to this new emerging hydrogen medicine type of idea for their various research projects. So a lot of research was inspired by Dr. Ota's article. And now, what is molecular hydrogen? Well, it's very simple. It sounds complicated, but hydrogen is the very smallest element. If you remember the periodic table of elements in high school, hydrogen was the smallest one, the first one on that chart. And just as it by itself, just you can't have just one hydrogen. It's without a bond of some sort, it just is not going to stay put, so to speak. So hydrogen needs to bond and isn't found all, just singularly. But interestingly enough, it can bond with itself. So if you have two hydrogens bonded together, that's molecular hydrogen. And that molecule is the smallest molecule, the lightest molecule, the most quickly to evaporate molecule on the planet. Most of the time, scientists in prior, let's say, to this century, considered that hydrogen was neutral, inert, didn't do much to the body one way or the other. However, the more recent research on molecular hydrogen is that it actually is not that at all. But it's rare to find just H2, like by the surface of the earth. Two hydrogen molecules. It's so light, it's just going to evaporate. So you have to constantly produce it somehow, either hydrogen pump or a water ionizer or something has to produce hydrogen freshly. It will evaporate. Now, a lot of times you'll have water stores or whatever that produce hydrogen water, or maybe bottled water that says it's hydrogen water, and it's just ridiculous. That hydrogen is long since gone. Another thing is if you put a whole bunch of hydrogen water in a gallon jug or 5-gallon jug, that's just not going to be a very practical solution. You need to pump hydrogen on the frequency that you're going to drink it. And that really pretty much necessitates, if you want hydrogen to round out your healthy nutrition, you will need to have some sort of a hydrogen producing device, such as a water ionizer or a hydrogen machine of some sort. Now, hydrogen is an extremely important molecule because it can enter it. We'll talk about its antioxidant properties later, but the fact that it can diffuse into cell membranes, mitochondria, blood-brain barrier is very significant because no other antioxidants can. So it can get into, let's say, mitochondria before any cell mutation would take place, acting preemptively on things like diseases or cancers or this kind of thing. Now, this is all in the theory stage, and there's no guarantees here because there just needs to be a lot more research. But research is really pointing in this direction that hydrogen can act as a protective molecule in the body. Let's just say that. I'll say more about it as we carry on down the page. Now, it diffuses so quickly into the various cells and into the mitochondria, into the brain, into all these different places so quickly that it's really almost instantaneous. I can actually feel some sort of a mental clarity within a couple of minutes of drinking ionized water. So that's how quickly that you can expect that hydrogen will diffuse. Now, why does this matter? Dissolved hydrogen influences biology in a new, unique way that was not discovered before. It opened a whole new line of inquiry and a whole new area for hundreds and hundreds of research projects. It suggests that water could be more than just a delivery vehicle or a hydrogen medium. Unlike some conditions, it dissolves gases, and electrochemical properties might also matter. This one reason Water ionizers and hydrogen water machines have received growing interest. Both are based in part on the idea that changing water chemistry may affect more than taste alone. The next question, of course, is how a tiny molecule like hydrogen is produced in the water in the first place. And that begins with understanding how a water ionizer works, which we'll talk about in the next section.